this is the first problem of Tip 2 contest 905. And in this problem, we are given a string S of length n consisting of lowercase letters and an integer k. So we need to check if it's possible to remove exactly k characters from the string S, and we need to remove them in such a way that the remaining characters can be rearranged into a palindrome. So if we have a string S of n characters and we need to remove k out of these, exactly k, so how many characters will be left? N minus k, right? So we just need to check whether it's possible for us to choose n minus k characters from the original string such that we can make a palindrome out of those. So how to do that? So for each of the characters, like there are 26 characters, count how many times each character is appearing in the string and just try to see that out of these 26 characters, can you choose some characters to make like n minus k characters? How would you do that? See, if this number is first of all odd, like first of all, you'll try to choose every like even number of characters from each A to Z, right? And try to fill it. And if at last this turns out to be left like this is 1 now, that means that at the beginning it was odd, then you can choose any number, any character if it's available, right? So finally, if these checks are satisfied, then you will say that yes, it's possible, otherwise no. Is it clear? Okay, so let me show you the implementation. So this is the implementation. In this, I've first taken n as input, then I've taken k as input. Afterwards, I've taken string s as input, and these are the remaining characters in the string after removing k characters. So first I have counted how many times each character is appearing in the string s. Then I'm going to remove minimum of rem, or like I'm going to take even number of characters from each from each count, and I'm going to remove this from rem. I'm going to remove this from x. And if this turns out that my rem is odd and e is still there, like e is more than 0, then decrease this rem by 1. So finally, if rem is 0, that means I'm able to get all the characters for my palindrome. I'll print yes, otherwise no. So this is a very straightforward problem, and there are I think this can be implemented in a much easier way. So anyways, but eventually you'll be doing the same thing. So let's go to the next problem. So this is the next problem. In this problem, we are given that we have an array A of size n and a number k, which is between 2 and 5. So we can choose in one operation, we can choose any index and increase ai by 1. So we have to find the minimum number of operations to make the product of all the numbers in the array divisible by k. So see, if k is between 2 and 5, see if k is 2 or 3 or 5, it should at least one number should be divisible by, if like k is one of these, it should be divisible by k. Otherwise, because these are prime numbers, you cannot form these numbers by multiplying two numbers. So that's why one of the numbers should have any of these as a, if k is 2, it should have 2 as a factor. So what we can do, we can iterate through the complete array, and we'll try to, if k is currently 2 for these three numbers, we'll do, if k is, let's say k is currently 2, we'll try to bring this to each number, we'll try to bring it to the closest multiple of k for when k is 2, 3 and 5. When k is 4, we'll do the same thing, but now we just have to keep in mind that it's possible that two even numbers are multiplied and then the complete product is divisible by 4. So how to do that? Just find how many numbers, do the same thing, and also do one more thing, that count the number of elements that are divisible by 2. So finally, your answer for 4 is nothing but the answer that you calculated from this part, or the answer that you minimum of this thing, or 2 minus count, and make sure that this count is at max 2. Like it's possible that you have 4 numbers which are multiple of 2. So you can do something like count is minimum of 2 comma 1, because you just need 2 numbers to make a multiple of 4, which are even, like two even numbers. So just count how many even numbers there are, and if it is more than 2, make the count equals to 2, and finally your answer is this. Like, what is your doubt for 4? Like this is what I was explaining for 4. What you need to do. Like you can unmute yourself and let me know.
Can you go through the for the 4 part quickly? I could not get it.
Like, did you understand 2, 3, and 5?
Yes, I got.
Yeah, you do the same thing for 4 also. Then there is one more thing, that instead of making one number complete multiple of 4, what you can do, you can just see how many, like just make 2 numbers multiple of 2's. Eventually you multiply these two, the complete product will be multiple of 4, right? So how to do this? Just count how many numbers are already multiple of 2's, and your answer is nothing but minimum of answer that you calculated from earlier part, or 2 minus count. Like you'll have to convert these many numbers to multiple of 2's. Is it clear now?
Okay.
Okay, so let me show you the implementation. So this is the implementation, and this, if k is 2, 3, or 5, just iterate through your array, and answer is minimum of answer comma the next multiple of k minus this thing, like how many steps do you need. So here we can print it. Otherwise, if k is 4, we have, like I have done the same thing, but just other than this, I have added this one extra line, like counting how many numbers are multiple of 2's. So once this is done, my count is minimum of count or 2, because I just need 2 elements, 2 even elements to make up 4, a multiple of 4. So then finally for 4, my answer is minimum of answer, that is the answer that I calculated from this part, or 2 minus count. And finally I can print it. So I hope this is clear. Going to the next problem. So in the next problem, we are given that we have an array of integers a1 to an, and we have to calculate the number of subarrays in this array such that that subarray is just occurring once in the as a subsequence in the complete array. So basically, if you have a array like this, and you are choosing, you have to count sub arrays like this, like alpha, beta, gamma should only occur here. Like if gamma is also here, then like this is a subsequence, alpha, beta, and gamma here, right? So you can have like this. So you just have to count the number of sub arrays which are only occurring once as a subsequence. So how to do this? See, if you have this array, it doesn't matter what is in between. The element which is at first and which is at the last, you shouldn't be able to choose this element before this. Like if x is here, if another x is here, then you can, without like instead of choosing this, you can choose this, right? So that's why it shouldn't be like before this x. If this is your start of your subarray, then x shouldn't appear before, and same for y. If y is occurring here, then y shouldn't occur after this thing. Why? If this is your end. Why? Because instead of choosing this, you can choose this in your subsequence. So this is the problem itself. Like this, just find all the, like just see that if this number is the last occurrence, like if let's say here is some alpha, so this alpha is the last occurrence of alpha in the complete subarray, then you just have to see how many betas are there, such that these betas are the first occurrences of their number, beta 1, beta 2, beta 3. So here you can end your subarray, and here you can start it. Is it making sense? Yes, no?
Yes.
So let me show you the implementation. So see, first of all, for each ith element, f of I will give me whether or not it is the first occurrence or not. So how to do this? Simply make a map and just see that if this element has not occurred before, f of I is 1. Then in map, mark that element as 1. Similarly, for L, vector L of I will give me whether at the ith position you have the last occurrence of any number or not. So how to do this? Just reverse iterate through your array and see whether if this array element has not occurred before, L of I is 1, and then mark this element as 1. Finally, this is the count. This is count is nothing but how many positions you have like visited till now, which had the first occurrence of a number, and answer will be the final answer. So f of I is added to count, that is number of positions that have the first occurrences. And instead of writing it like this, I can write something like, if L of I is equals to 1, that means that this is the last occurrence, then answer plus equals to count of I. So this is, if this is the last occurrence of of some number, then I'll add this count, like all the places where I can start my subarray to my answer. Finally, I can print it. Is it clear? Yes, no, anything? Okay. So let's go to the next problem. So D1, in this problem, we are given that we have two arrays A1, A and B. And before applying any operation, we can reorder the elements of two arrays as we wish. Then in one operation, we can perform both of the following actions if the array if the arrays are not empty. So what we can do, we can choose any element from array A and remove it, and then choose any element from array B and remove it. So the remaining elements just fill all the gaps, and they are shifted to form a new array. So finally, what we have to do, so let K be the final size of both the arrays. We need to find the minimum number of operations such that in final array AI is less than BI for all positions. Now this is just we have to solve this for since this problem seemed very easy, what we have to do, we have to solve this problem for m different cases. And for the ith case, array A, in array A we are given n minus 1 elements, that is from, let me explain it here. So in for first, we have to solve it for m cases. In first case, in array A, the first element is this, and the remaining elements are given to us in the input. This is given to us in the input, and array B is also given to us in the input. But for first case, the first element is 1, and in the easier version, m is always 1. But in later on, in the second problem, m can be up till 1e9, that is 10 to the power 9, and we have to solve for each case. So for first case, the first value will be 1 only, but in the next case, the first value will be 2. In the next case, the first value will be 3, and the remaining input is given to us in the, this is in the input, right? And what we have to do, in first case, let's solve the easier problem first. So we have 1 here, and we have n minus 1 array elements of array A in the input. Then we have n elements of B. Now what we can do, we can rearrange these elements in any order as we wish, and we just have to afterwards delete some values, delete some elements in both arrays, such that finally, let's say this is array A and this is array B. So this is less than this. This is this is followed for all the three elements. So see, if we can rearrange in any order, we just want to minimize the number of operations, that is minimize the number of elements that we have to delete, right? So what we can do, let's say this is our array A and this is our array B. We'll pick up the maximum, this is a greedy problem. We'll pick the maximum value out of these, and let's say this is the sorted order. So for this X, first of all, I'll try to see whether or not there is some Y in array B such that if there is a Y such that X is less than Y. If this is possible, then I can say that X and Y can finally end up in my final these arrays. Otherwise, I'll have to delete this X. So I'll just count how many elements do I need to delete from this array, and that is nothing but the minimum number of operations that I need to perform, right? Is it making sense? So now this problem is converted into a greedy problem. See, you are given two arrays. You just have to find how many pairs you can have such that AI is less than BI. So what we can do, first pick up the maximum value in this. Why maximum? Because see, if you choose if you go in other direction, first of all, you should try, see if there is a value which is like, see if there is a value, this is AI and this is the maximum value. So for this, I'm saying like this was the maximum. If AI is less than BI, then you should take this. Why? Because there are other values that also can also take this, but you're also getting one pair here, right? If you don't take this, this will get removed, and probably you can take this via from this value. This is lesser than AI, but this will eventually also give you one only. This will also contribute one only. So why not take this? And if in case AI was more than BI, then you know for sure that this is the maximum element, right? And if you're not having anything for like this, then you will have to remove it. There is no other case. So that's why just like sort, if you like don't sort, like if you have all these values in multi-set, just iterate from the maximum value to minimum value in array A, and each time just choose the maximum value and try to find that in your multi-set for B, is there any value which is more than, or more than, not equals to, exactly like strictly more than AI in your multi-set B. If there is, then you can have one of these pairs. So this way you'll try to maximize these kinds of pairs. Finally, your answer is nothing but n minus number of pairs that you got like this. Is it clear? This is for easy version. Is it clear? Yes, no? Okay, it's clear. So let me show the implementation for this quickly. So see, first I'm taking n and m, then I'm taking array A. In array A, the first element is 1 only. Why? Because in this case, m is 1. So the first element is 1, then I'm giving, like, I'm taking all the other values, all the other array elements as input. This is also taking array B as input. Then inserting all the array elements, first array elements in multiset A and second array elements in multiset B. This count is nothing but how many elements do I need to, like, do I count as actually the number of elements, like the number of pairs that I can have finally. Like count is not the answer. Count is this. Like in my implementation, count is this thing. The number of elements present like this. Number of pairs that I can have. So I'm first doing while my multiset is having size. So I'm finding multiset.upper bound will give me whether or not there is a strictly more element than this thing. So this is nothing but the biggest element in multiset A. If there is a more than, like, if this is not equal to multiset B dot end, then I'll increase my count by once and I'll erase this element from my multiset B. Eventually, I'll always keep erasing the biggest element from multiset A. Finally, my answer is nothing but n minus the number of pairs that I can have like this, in which AI is less than BI. Is it clear? Okay. So now how to solve this problem when M is very large? M is very large. See, we solved when M was 1. So what we did, this was our array A, this was our array B. So here we had 1. And we're just trying to, after sorting, let's say we were just trying to like see, okay, this element is more than, like this element is less than this element is less than this element, this element is less than this element. These two elements are not less than anything, but this element is like the next bigger element, just next bigger element. Let me write these values. So in this you can see like 6 had nothing, like you can choose nothing from second array that is bigger than 6. Again, you can choose nothing. For 4, next bigger element will be 5. For 3, next bigger element will be 4. For 2, next bigger element will be 3. So this way we got count. For 1 it will be 2, right? So this way we got our count as 4. We have 4 pairs. So our answer will be n minus 4, which is 6 minus 4, which is 2. So we had to erase 2 elements from both of these. And 2 elements that were erased were these 2 from first array and maybe these 2 from the second array. But now we have to, instead of 1, we first have to take 1, then 2, then 3, all the way up till m, right? So how to do this? See, you just need to see after this 2, once this value becomes 2, 2, 3, 4 like this, we can either take some of the values, see, 2, 3, 4, once it becomes 2, it will, this value will eventually start can take 5 also, right? Once it cannot take this 2, but it can take 5. At 3 also, this can be paired up with 5. At 4 also, it can be paired with 5. But after that point, it cannot be paired with anything, right? If let's say there was a 7 also, then this 7 would have been already taken by this, right? There was a 7.
Yes.
And this 7 was paired. This 5 is also paired. Like, you cannot take this 5. Then this one would have already only have got 2. And after that point, couldn't be paired up with anything. You might think, why cannot? If I make this 2, I'll pair it with this 3. But this is already paired, right? This is already giving you one value. Like, you remove this connection and you add this connection. If this is also 2, what's the point of doing this? Like, you're subtracting 1 from your count and adding 1 to your count. Count is nothing but how many pairs do you have. So you just have to see what is the element that you are pairing it with. Like, what is the maximum element that you can pair it with? So in this case, it is 2. Earlier it was 5. After that point, once the element becomes bigger than this, like, you have to go from 1 to m, right? So once the element becomes bigger than this, there is no point. Like, this value cannot be paired with anything. So after that point, your pairs will be count minus 1. Before that point, your pairs are count. So just like how many times you will get count up till this thing from 1 to 5, and after that from 5 to m, you will get this thing count minus 1. So this is your final answer. Is that clear?
Okay भैया, हाँ समझ में आ गया.
Like, yes, like your basic idea should be to get an idea and then try to solve this problem. See, if you try to mug up my solution, you won't learn. But the basic point is, if you're like, see, and it's also possible, see, if your rating is quite low, don't assume that, okay, you won't understand. Try to get an idea. I think the idea for today's problems were very simple. In this, you first came up with greedy for first D1, or maybe whatever it was for division 3, and then try to solve, like, see what is happening when this value becomes big. So, okay, you got the idea. Now but anyway, if you're confused, let me know. I'll explain it again. So see, the solution is very same. The thing that I've implemented here is the same here. The only difference is, like, here now, like, I can check multiset A dot size also. Like, when this size becomes 1, that means now I have the last element, and my array A, I'm inserting again 1 only. So this will be the last element which is left. Why? Because array A is having elements from 1 to n, like 1 to 10 to the power 9. So I'm always removing the maximum element, right? I'm always removing the maximum element only. So at the end, my array, like multiset, will have only 1 left because it is the lowest element, which is an array. It is possible that there are more than 1, but eventually last thing will be 1 only. So let's cover this in a moment. But other than that, the solution is exactly same, right? This is what I was, no need of this. This is what I was doing in last part also. Doing the same thing here. So till my multiset is having more than 1 size, I'll do the exactly same thing. When multiset size becomes 1, that means I'm at the last position. I'm at the last, or not the last, but I'm at the smallest value. That is, if this is my array A, I have this thing. Everything I have paired with each one of these. Like, I have tried to pair. Now there will be some elements left which were not paired from multiset B. So first of all, I'll see whether there is some element which is more than current. This can be written as 1 also, because it will be 1 only. That is the element which is left. If there is an element in multiset B which is more than 1, then I can pair this also, at least sometimes, for some moment, right? For some cases. So I'll pick the maximum out of those. Then I'll increase my count by 1. Why count? Count is the number of pairs. Here, count was nothing but the number of matchings that I'm getting. So this is the count. Now, eventually, this is my answer, right? N minus count. How many operations do I want? Count is nothing but the matching, the pairs such that AI, like all the pairs where AI is, I can get such that AI is more than BJ. So this is count. But how many elements do I have to remove? It is nothing but N minus count. This is the number of operations. So that's why I have replaced count with n minus count. So this is actually a bad practice because earlier count was denoting something else and now it is denoting something completely else. So we should have variable names like as they are used, not like changing these. So but count is now nothing but the number of operations. So if m is more than x, x is nothing but the maximum element. So if m is more than x, that is my my value m is nothing but like this value will go from 1 to m, right? So if this and x is the maximum that is present in multiset B, so I can pair this from 1 to x minus 1. I'll get count number of operations. After this point, once it becomes x from x to m, I'll get count plus 1 operation because I'll have to remove this also now. This cannot be paired with anything. So the same thing is done here. So while m is more than x, I have multiplied count with x minus 1. That is from 1 to x. And then I will have count plus 1 operations from x to m. So m minus x plus 1. Otherwise, if m is already less than x, I won't go up till x. So every time I will have count operations only up till m. Is it clear? Is this thing clear?
Yes, bhaiya, it's clear.
Yes. And now what if multiset B was not having elements like more than one? That means I cannot have this pair, like this thing mapped or match even once. So then my answer is nothing but just do n minus count, whatever I had till now, and count into m. Right? I won't do count plus plus here. Nothing got matched, right? So simply count and this thing. So finally I can print my answer. So let's go to this is clear, right?
हाँ भैया ये clear है. That's quite clear.
Okay, so let's go to the next problem. So D1 and D2 are both clear. I have explained both D1 and D2. Now E problem. Like E problem is also very simple. If you have a just like basic idea of graph and that shortest path. This is a very simple problem. So first let me explain the problem. In this problem, we are given that Berlin is a country with ancient history and where roads are built and destroyed for centuries. Now it is known that there always were NCTs. There are T time moments. So the time moments are numbered from 1 to T. I'll explain this, what is meant by this time moments in a second. But each record contains a list of bidirectional roads and between two cities and which could be used to travel in Berlin at specific moments in time. Now you have discovered a time machine that transports you between key moments. Unfortunately, you cannot choose what point in time to end up at, but you know the order of k time moments, AI. And basically like, okay, this is simply some story. So the point is, since there is a little time between travels, when you find yourself in that next key moment of time, you can only travel at most once. Like you can choose only one road and travel through it, and then you will be eventually gone to next time moment. So you have to find the minimum number of time moments after which you can end up from one to city n. So first of all, let me explain this problem. Like the language is difficult. The problem is, let's say at time one, like this is time instance one, like this was the way, like there are 5 cities and these are the number of roads. Now at time moment 2, what will happen? This is like there are those 5 cities only, but the point is now they're connected in different manner. And at time 3, you're given another thing. Like these two are connected and these are connected. So at 3 different times, you have 3 different orientation of edges. Like this is the way they are connected. And now you're given the order of like in which time moments, like in which the machine will send you to different times. So first it will send you to 2, then it will send you to 1, then it will again send you to 2, then 1, then 1, then 3. And let's say this is vertex 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. And you have to end from vertex 1 to 5. The only thing is, like, you cannot, like, even if this was connected like this is not there, but if it was there, you couldn't have done something like, oh, okay, I'll go at time. Okay, let's take another example. Okay, initially, like at start, we are at this second. This is the second time instance, right? So we are at second time instance. So you cannot say, okay, in this we can, but let's say this edge was not there and this was like this. But let's say if this was also there, then you cannot directly say that, okay, this is wrong. Okay, this is right. So if you are at time instance 2, you cannot say that at 2, this is like I can find a path from 1 to 5, right? So you cannot go like this, like, okay, I'll go from here to here and then I'll go from here to here, because once you do one step, once you take one step, after that eventually this will get changed. Like from time machine will send you to first key moment, and in that you don't have an edge from 3 to 5. So this edge doesn't exist in this. You can take one step. Do you get my point?
Yes,
Like,
भैया.
either you can take one step or you can stay there. So
After each orientation, after each second, the orientation of the
yes,
mass is actually
you
changing.
can see it like that also. After each second, the orientation will change. Like it will go from 2 to 1, then to 2, then to 1, then to 1, then to 3. And you can take at max one step in each second. So like the solution for this problem is, like, see, if this was the scenario from 1, like you are here, this is the orientation, you can go to 3, okay, then you get back to this orientation. In this, you cannot go anywhere. So okay, so again at 3 you cannot go anywhere, you are at 3 only. Then again this orientation is there, again you are at 3 only. So again this one orientation you cannot go, then again this one orientation, in this you end up at 2, and then this 3 orientation, like, no, you are at 3 only, and then at 3 in this third orientation, then you can go to 5, right, from this 3. So eventually how many times, like for how many times you have to wait? You have to wait from 1, 2, 3, 4, 5, 6. At after key moment 6 only, you'll end up at 5. So you have to minimize this thing. Let's suppose here after this there was like this also. So you could have maybe gone to 5 at this instance also, but the answer is 6, because after 6 you can end up at 5, right? So how to solve this problem? See, these are the edges, right? These are the edges. So what we can do, there is an edge between 1 and 2, and we can, for this edge, we can find at what all time instances this edge will be there. Like it is at time instance 1, and it is only at time instance 1. So let me write that thing first. So there's an edge between 1 and 2, and it is at time instance 1. Between 2 to 3, it is at only 1. Between 1 and 3, okay, from between 2 and 3, it is at this third timestamp also, right? And between 1 and 3, it is at timestamp 2. Between 4 and 3, it is at 1. Between 3 and 5, it is at
4 and 3 पर शायद नहीं है 4 and 3 की कोई
4 and 3. What? Okay, 4 and 3. Yes, this is wrong. 4 and 5 it is there. Sorry. This is 4 and 5. So this way, for each edge, we can find what all time at timestamps this edge is there. So now this is a simple Dijkstra's problem. See, what we have to do, we start from node 1. We can go to each of the vertices, neighboring vertices, but during this, let's say this is the current time, the minimum time, like we'll calculate a distance d, what we calculate during Dijkstra's, but this will give us the minimum time distance I. This is distance I. So this will give us minimum time to reach vertex I. So what we can do, if we are current at this vertex and some value d, distance I has value d. So we know this edge is going from 1 to, let's say, some v. So 1 to v, we know all the timestamps at which this edge will be there, right? This will be at like, let's say this edge will be at timestamp 1 and 3. So what we can do, right now we are at time d. So we will just see after time d, we are already at this time, third time. So we will just see after third time, when will I get the first time instance? like first key moment, because at that time this edge will be there, right? So if this edge will be there, I can shift from this vertex to this vertex only then when time will be, when that key moment will be there. And after D, I just have to find the first instance when I'll get 1 as the key moment or 3 as the key moment. So minimum of these. If there was 1, 3, 5, 6. So out of all of these key moments, I like this edge will be present in all of these key moments. So I just need to find which of these first occur after D. Like which of these will occur first after D? If D is this, when will 1 occur, when will 3 occur, when will 5 occur, and when will 6 occur? Because for each of these, there will be an edge and I can shift from 1 to V. Is it clear?
Yes, Bhaiya.
Okay, I'll repeat this once. See, for each edge, we have calculated what are all the timestamps, what are all the key, these are key moments when this edge will be present, right? 1 to 2 will be present at key moment 1, 2 to 3 will be present at key moment 1 and 3. So now if let's say I have to calculate this distance I, which will give me minimum time to reach this vertex I from vertex 1. Initially, like I start from 1. Now for each of the neighboring, like these vertices, I just see that, okay, 1 to V, I need to see this vertex 1 to, I need to see this edge 1 to V. So I have already calculated at what key moments it will be available. So it is available at key moment 1, key moment 3, key moment 5, and key moment 6. Right now, the minimum time to reach this vertex is D itself. So in this array, this is the key moments, like the order in which key moments, like the time machine will send you to key moments. So if you are at third moment right now, you just have to see, like you are at third time, and these key moments will come further. So you just have to see which of these occur first. Like when will you be at 1 key moment, when will you be at 3 key moment? Because in each of these key moments, this edge will be there and you can go from 1 to V. So just find the minimum of these, like the minimum, what is the first, when is, at what time after D each of these appear. Is it clear? And you keep doing this, finally the distance of n will be your answer the first time when you are able to reach node n or city n. Is it clear?
Yes, Bhaiya.
So now it's just implementation. So let me show you the code. Like I have used some set, or like it will be much more clear there.
Kind of, we are going to find the upper bound after D.
Yes, I'll show you that. So first of all, this is n and t is the number of key moments. So I'm taking, this is the graph that I'll generate, and this is, okay, this is like u and v is available at this key moment. So j is going from 0 to t, and j plus 1 simply means that at first moment there's an edge between u and v, and this is the graph. Now I'm taking the k, like the order in which, like the time machine is going to send me in different key moments. So this is that. Now next, this is will be used like next, like when is ai, like ai is nothing between, like ai is nothing but between like the time key moment, right? A was the order and this is the key moment. So next is nothing but all the indices in at which my ai is occurring. Like I'll be, let's say I have something like 2 2 3 1 1 3 2. So at 1 is occurring at, write down the indices first, 1 2 3 4 5 6, and this one is at 7. So 1 is occurring at 4 and 5, 2 is occurring at 1 2 7, 3 is occurring at 3 and 6. So this is what I have stored in my next set. So like these will be sorted in, like stored in sorted order only. We can use vector also, we don't have to use set. But this is what next of 1 will be this thing, next of 2 will be this thing, like the positions at which these values are occurring. Okay, this is the distance vector that we have to calculate. Distance of 0 is initially 1 because it is given us in the input. Now this is just for Dijkstra's. Okay, now this is the logic. So first choose the minimum, like the node which is reached right now at the minimum time. Remove that node from the set. Now this is just a check that you are not going through a node if it's not required. Like if that node has already been iterated earlier. Otherwise, for all the vertices that are connected to this node, find the minimum time that you can reach to vertex V. How will you do that? There is an edge from U to V, and these are all the possible key instances, key moments at which this edge existed. So for each of those key moments, find the lower bound. Like for this key moment, after D, what is the first index at which this thing will occur again? So that is stored in temp. Temp is having the minimum of all of those possibilities. Now you have to increase temp by 1. Why? Because you have already traveled once, right? You have already traveled once. Now, if you want to go to some other third vertex, the time that you took from here to here, you can only, in each second, you can only travel once. So this will be 2. So that's why increase this by 1. Now, if the distance of V, time to reach V, was more than temp, update your value. Finally, check if distance of n-1 was already 1e9, make it 0. Why? Because eventually we are going to print this. Why we are printing -1? Because when we are adding 1, we are adding 1 because this simply means that we will be able to travel from this node after this time, from or after this time. But we eventually reach, like we don't have to travel from nth node to anywhere, right? We can travel from this node after D or at D, but we reached this node at D-1 because we started at, like in this second, we eventually reached this node. At third second, we traveled and reached this node at third second. We can start traveling from this node from fourth second. So D is 4, but we reached this node at 3. So that's why temp minus. That's why.
Yeah, got your point.
So I hope this is clear. Like this is a very basic problem if you like try to see it like using graphs and etc. But like you have to figure out how to just go from one node to other node and when to choose like what key moments.
That moment वाला जो part था वो काफी थोड़ा सा समझने में दिक्कत हुई थी.
Yes, like so this problem will be like a little like rated higher. So like try solving this using pen and paper and then you'll get a better idea. Yeah.
Thank you, भैया.
So thanks for joining and bye-bye.